If it's like a piece of arithmetic, for example, then I'm not going to bother mocking up the entire deployment initialization and just go straight to testing the stateless arithmetic side and showing that it underflows or it rounds down to 0 or something like that. It's very challenging for larger code bases to be able to do that, especially if the exploit relies on something that relies on the system being set up.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%.
GM everyone, my name is Tagachi, the host of Scraping Bits, and today I'm with Nat from Trail of Bits. How's it going?
Yeah, pretty good. How about you?
Not too bad, not too bad. Just for some context of who you are, who are you and what do you do?
Yeah, I'm a security engineer at Trail of Bits. I generally do a lot of code reviews, use a lot of like automated tooling such as fuzzing. I started to get into blockchain. I actually started in 2017, so it's been quite a while since being in kind of getting into the space. I was doing development for about 3 years, and now I've, I guess, been a security engineer for about 3, so I'm about half.
Were you doing like front end before, or was it like back end, full stack?
Smart contracts.
Oh, right. Okay. Was that it?
Yep.
You just started with 3?
I was in school doing computer science. I graduated in 2020, so I was basically doing hackathons outside of school, got me into ETH Waterloo. So I started just kind of a dive into blockchain 2017. By that time, pretty much most of my hackathons after that were all blockchain related. So yeah, I got lucky. I got in early.
Nice. Yeah, I started just like complete smart contracts and then somehow went down the rabbit hole into where I am now of just automated analysis of, auditing and blockchain, which is never thought I would do this, but here we are.
It's a rabbit hole.
Yeah. And what was kind of like your pathway into getting a Trail of Bits? Where you're just doing like, CTFs and then you kind of got picked up or something else?
Yeah, so I actually, once I graduated in 2020, by that point, I'd already been doing smart contract development for a while. I think there's one side, I do still love development. I do think there's one side effect, which is, for me at least, it was too challenging for me to like fall asleep at night just because what if my code has bugs, or what if the code that I've written or my tests aren't actually conclusive, even though I have 100% test coverage. So the transition into kind of the security side of things was pretty natural. I'd already been reading audit reports, reading like using static analysis and any kind of tooling. And yeah, I think the opportunity at Trail of Bits just popped up. And I think from that point on, even before that, to be honest, I was pretty much neck deep into security already, just without really doing security stuff at work. So yeah, Trail of Bits ended up opening a position, and yeah, it worked out really well.
Yeah, the mindset from a developer to cybersecurity auditing is completely different. I think majority of devs don't even consider the security aspect of the protocol because they're always thinking of, does the code work to begin with? As in, cross-contract interactions, something else depends on it, or it depends on something else. If that, dependency, whatever it is, has some kind of flaw, then that the original contract has a flaw. And so you basically have to do like 2 audits, one of the actual underlying dependency protocol and then your own protocol, which can get quite challenging and time consuming. And I don't think a lot of devs even do that or even consider it, right? So I wonder what that kind of process is like for you. If you get given a project and it has dependencies of external contracts, do you also look at those external contracts or you just kind of ignore them?
So I think it depends whether I'm kind of in the role of a developer or in the role of a security reviewer. I think for me, at least as a developer, that was my opportunity to like dig into dependencies, look at like all of the potential bugs that could happen out of those dependencies, as well as like the code that I've written. It's kind of harder to do that for security reviews just because it's time boxed. It's
right.
There's kind of more you have to be more strategic with like what areas you're focusing on. You don't necessarily, I guess in both cases you don't have unlimited time, but for security reviews in general, you're generally very tightly scoped with like what you want to focus on.
Right.
I do think there's definitely a need for like all projects to make sure that they're checking what can go wrong with like dependencies, where, you know, if there's like an upgraded dependency, whether it's like a bug fix, that kind of thing. Like I think there's a lot of intricacies once you start integrating with all these different protocols, which is challenging, especially for like smart contracts and like blockchain code, just because the process of even just checking your code and whether it does what it expects is so much harder to actually verify.
Yeah, because there's so many contexts that you have to consider, right? Like if someone deposits without going through a function or sends tokens to the contract and it doesn't account for it in a fallback or anything like that, then it's just kind of impossible to think of all these situations, which forces you to do fuzzing, basically. And I think anybody that doesn't do fuzzing is, you know, not covered as much as they actually think they are. And I think even having a sophisticated fuzzer as well, something capable of finding, you know, multiple dependencies, okay, what can actually go wrong, which is incredibly difficult because so many things can depend on other things, and you know, more protocols come out, or an upgrade comes out, which completely changes the scope and nobody's even considered it. So during this short scope that you're given for an audit, what is your kind of go-to to get the best, you know, coverage, most efficient kind of way of finding the criticals, I think, and making sure that you've kind of hit all corners or as best as you can within that time slot?
Yeah, that's a great question. I think honestly, developer teams can get like a really good head start as to like finding low-hanging fruit. Something like running static analysis with like Slither and like, you know, having like 100%, you know, statement and branch coverage. That allows, I think, for any kind of security review, us as auditors to really focus on the core issues of like architecture, complex issues, or issues related to like dependencies. And so I think generally at least when we start reviews, we start with running Slither, running to see like how many results are there? Is this a tool that like the development team has used before? And kind of be able to determine, not just report the low-hanging fruit, but determine how mature and how much effort has been put in to preventing bugs as they're being developed. And then once that's done, I think the whole process starts around trying to get a mental model of like the code base. What does it do? Who interacts with it? What's all the expected behavior? I think that's a lot of information that ideally is probably in like a spec document or documentation provided by clients. But I think there's always a trade-off between updating documentation and updating code. And so that's a given, just given the limited time. So generally just getting that mental model, and then usually that gives us kind of an idea as to like, is fuzzing realistic in this time frame? And if not, then we try to provide recommendations for, if you're implementing fuzzing in the future, this is where we recommend you start. I think that's a common thing that you'll see in some of our reports, just because even though we're time limited on, you know, what we can get done in like a week or two, we still want to provide as much value as possible that are kind of outside the core vulnerabilities and the issues.
Fuzzer is really just hybrid then. It's kind of, you need a kind of a manual input to get it running. Is that kind of correct?
Yes, our fuzzers, we have like two, one that's kind of in beta called Medusa, and then we have Echidna, which both of them are property-based testers. So you do essentially specify properties that you expect for like the system to hold true in terms of state. And then the fuzzer will essentially, it has a series of different modes, but at a high level will essentially call your smart contract and see whether violations of that state are possible.
Okay, right. So you do have to take the time to write the properties to begin with. and see how it plays out. I wonder if there's any kind of way of automating these properties. Have you thought of this at all?
We do have like an extension of Slither that automatically generates properties for something small like an ERC20 token. We also have a different repo. It's called Critic Properties, and that's essentially property tests on like ERC 462 and a series of different tokens like ERC20 and 721 that can essentially be picked up and be used by projects to determine like are there deviations between like expected behavior and the information, especially that's identified in the token standards. I think as time progresses, I think we'll continue to build out those properties so that it's easier to be able to pick them up and apply them to different code bases. I think there's just a ton of potential in these fuzzing tools, in these automated tools that allows us to use that in combination with manual review to find the fun bugs.
Yeah, fuzzing is such a powerful thing. I think in crypto, it's in such an infancy stage where there's so much innovation possible. And it's kind of surprising that, the big firms, Consensus, even Trailer Bits, don't really have that very well developed fuzzers, at least from my perspective, because I've been doing too much research on it. But just the space in general, I mean, it's a lot better than what it was before, but it's still kind of infant, in my opinion, and it should be a whole lot better. But maybe the resources aren't really addressed. And, it is a really tough question or tough problem to solve. But yeah, I want to see how that goes. But I wonder if you do any like active fuzzing as well. So, for example, I have my account and I'm going to send the contract like, 100 or 1,000 USDC and then run the function, then one without that transfer, and then, not approving and then approving, stuff like that.
Yeah, so with the way that our fuzzers work, it'll essentially save like a corpus of all the exploit functions, all the kind of unique call stacks and call traces that look interesting so that the next time the fuzzer runs, it's able to reuse them. So in the case of like, for example, transfer from reverting because you don't have approvals, the next time like Echidna is going to essentially try to do like a transfer from by like, for example, calling the approve and then calling mint to see whether like there are combinations that make the different paths true. So it's essentially coverage based. That means that like if you do have kind of a long running fuzzing campaign on your code base, that you're able to like make use of pretty complex exploits or a long at least list of like function calls. So it's definitely true that in general, I think the space, we just need to see more adoption and like usage of fuzzing. I think I'm excited to see kind of in the future where we end up with like unit tests, for example. They should be pretty much standard across all code bases. I think we're all looking forward to a future where fuzzing is kind of that standard.
I think even generating these tests would be great. I think a tool that would just spit out all the actual properties of the contracts to which the developer can just check if they're true would be really good, because then you can just differentiate between your documentation and your code base just from that. You wouldn't even have to read your code actually.
Yeah, I do think invariant I think the tricky thing with property based invariant testing is like actually finding what properties you should test, and then obviously the other complex part is going to be converting that into code and making sure you're doing that correctly. I definitely think like the first case of that, like actually finding the properties, that's a constant struggle. I think it's a slightly different mindset that you have to adapt to look at your code in terms of like what are properties that should hold true as opposed to like what a function does. So there's a little bit of a paradigm shift that's needed in terms of like how you look at your code there. So it's definitely a constant struggle.
I guess if it just spits out like what is actually true in the code in these kind of properties, and you could just look at them and be like, wait, that's not actually meant to be true, if that makes sense. I don't know if anybody's actually done that, but it'd be, I think, a great tool to look into. Yeah. And I guess like, let's say, you've done all the recon on the project and you want to go straight for the criticals, right? What do you like really look for that you've kind of like honed in over the past years of, okay, this is where I should look first, this is where I should go next?
Yeah, that's a great question. For me, at least, there's kind of a few different areas that like require kind of closer focus and like additional attention. I think one is anywhere where like funds are being transferred in and out, and just making sure like those calculations are correct, especially for like DeFi protocols, that you're not just checking the movement of funds, but like the calculation of, how much goes in and out. I think focusing on access controls in terms of like who's allowed to call, a function, are they like, do these actually match, the ones that are expected? I think it's a practice to be able to kind of build that mental model of that code base. But once you're there, it should be easier to like determine not just the criticals, but like unexpected behavior, deviations, properties. It just kind of opens up that door.
Okay. Yeah, that makes sense. And, if it's a massive code base as well, let's say it has like 20, 30 different Solidity files, just some gigantic Goliath protocol. How do you know when to kind of switch between these different contracts and basically when to stop looking at one contract and move on to another one and then kind of connect them?
Yeah, definitely. I think that's something that's been very apparent in kind of the recent years of like code bases growing significantly, at least from 2017. I think from a reviewer perspective, there's kind of two ways that at least I typically go about it. One is start with like the smaller stateless libraries and figure out like, what is expected behavior of the library and like how is it used in the infrastructure without even thinking about like contract flows and like what the contract is doing. That gives you an idea at the very least of, in terms of like, calculations or like libraries, at least what that tiny subset of the contracts are doing. And it gives you a little bit more context. But I think eventually switching over to like tracking, what is the entry point to a contract, being able to trace the entire call stack and the flow through different contracts and be able to understand like if a user deposits into your system, what functions are being called, what arguments are being validated, what state variables are changing, that kind of thing, I think makes those large code bases slightly easier to handle, just because you're looking at the code base with kind of a subset of it in mind as opposed to all those lines of code.
Makes sense, yeah. And when you're given one of these massive protocols, or even just any protocol, what are the kind of most common problems you even face as an auditor that kind of make it difficult for you to do your job?
Yeah, that's a great question. I think it does still stem back to kind of that point around lack of documentation, just because,
Right,
especially for larger code bases, we need that documentation. Like that documentation is much more important to be able to, as I mentioned, build that mental model, but build that quicker. So that documentation will help you, or will help me at least, get an idea of like what the code base, what at least the developers were intending the code base to do, which helps a lot because now I'm able to determine like how to split up reviewing, how to like differentiate different components, what to look out for, that kind of thing. I also think having clear and explicit like integration tests will help a lot because I mean the tests don't just tell you whether your code behaves as you expect. I think the tests, as like at least for me going through it, tells me like what is the expected contract flow, like what are functions that users are going to call in sequence, like how basically tells me like how a user is going to interact with like a contract. And so being able to like, I guess using all of these, I think they all behave a little bit like hints for actually understanding the code base. And they sound pretty small, but like if we have a review and we have like, integration tests and we have like fuzzing tests and documentation, for example, in like Nat spec on all of the functions, it means that we actually like get onboarded and like into the code base much quicker than if we didn't.
I mean, let's say they didn't have, any tests or any documentation, no deployment scripts. How do you really build like the proof of concept to prove that it is vulnerable? Like, I guess, first of all, you need to initialize this contract, right? And if it's a massive code base, that can be very difficult. And then, once you have that initialized contract, if you do have it, then you need to build this proof of concept, but that is exploitable. So I wonder what your process is for actually building the proof of concept and generating the exploit?
That's a fantastic question. I think it very much depends on the exploit and like what is actually being exploited and what's relevant. For me, at least, if it's like a piece of arithmetic, for example, then I'm probably not going to bother mocking up like the entire deployment and initialization and just go straight to like testing like the stateless arithmetic side and showing that it underflows or it rounds down to 0 or something like that. Yeah, it's very challenging for larger code bases to be able to do that, especially if the exploit relies on something that relies on the system being set up. I do think that's kind of an opportunity for like us to be able to essentially work with the developer and kind of explain like the benefits of, I don't know, unit testing and using these frameworks so that like we can kind of help at least guide them in setting it up and providing guidance there so that as they continue developing their software, they're able to get like unit tests set up, they're able to get fuzzing up. So it's definitely a bit of an education piece there too.
Yeah, I think that's one of the main problems with pre-deployment auditing versus post-deployment is because post-deployment has already got the context. You can just fork it, spin up a proof of concept in like Foundry basically instantly. Yeah. Whereas pre-deployment, you don't even know if it is actually exploitable unless you run it. Yep. And, the biggest hindrance of that is the initialization. And I wonder if there's any, let's say you had to automate this, right? I guess what would your go-to approach be at an abstract level? So think about the way you manually do it, and then what are the kind of steps you take to get to that point? What do you look for to get to the initialization? For example, like, let's say Uniswap, right? You have the factory, and then you have to create the pools. But in order to create the pools, you need to create the tokens. And so you have to deploy the tokens and use those tokens on the factory to get the pool. So obviously there is some kind of like pathway, but then to automate that, obviously you would have to find out what depends on what else. Yeah. But for a complex thing, it might depend on multiple things. So I guess what is your abstract approach if you were to automate it?
Yeah, that's a great question. I think it's challenging to answer just because each contract and like each infrastructure relies on such different parameters to like initialize and get it set up. Like in some cases we'll have to, as you mentioned, like create like 2 ERC20 tokens, and that's relatively straightforward, as in you can kind of just deploy like tokens. But I think in other cases where it's like you have to get like a whole system set up that's because it relies on another DeFi protocol, I think that's pretty hard to abstract it into something that's like almost reproducible. I would guess that the most efficient way to do it would be like, for example, if you need to deploy an ERC20 token, then be able to use maybe inbuilt, like as in be able to use kind of reuse like deployments of like those tokens. And if you need something else, then kind of use it as a library rather than something that is like completely automated. I do think that's one thing that our properties repo does pretty well, because it essentially provides like property-based tests for the ERC20, but also for 4626 and math libraries. And so that's kind of similar to being able to like take these property tests and apply it on any code bases that use those functionalities.
Yeah, I think if it's already using a deployed contract, then obviously you can just fork that and then deploy it on the fork. But if it's like a whole ecosystem that's being deployed, then you're basically fuzzing for an initialization.
Yeah.
It can get quite complex if it requires a certain context, and then that requires, a custom contract, and then you have constructors, and then maybe you have a contract that has a function. So it's like best of both worlds. Not really.
Yeah, 100%.
Yeah, it's an interesting problem, but if you were to automate like a post-deployment one, it's really just fork, find what's there, and then just generate the exploit. But for pre-deployment, you have this extra step which just kind of hurts, I think, fuzzes for pre-deployment, and so people are just stuck with stack analysis for it, which is fine, but could get a lot better if you have this initialized kind of, I guess, state. I mean, I think it is possible without the initialization, but it would definitely help in ways, I think.
Yeah, definitely. I think it would help. And I think the more that we see people using like deployment scripts, we do have tooling like at TrailBits that allows you to essentially use like a deployment script and be able to essentially copy or like snapshot a view of like the blockchain or your local blockchain at right after deployment so that the fuzzer can like start testing there. And what that requires is pretty much just like a deployment script that you would use to like deploy your project. I do think like there's definitely tooling out there that like allows you to kind of get a boost in being able to reuse code that like you otherwise would have just used for deployment and use it for testing as well. But yeah, I think there's definitely like a learning curve there, not just with these additional tools, but with finding these properties and like actually implementing them in the first place.
Yeah, and property testing is such a big deal when it comes to fuzzing as well, because that's kind of how you find a vulnerability. And I've read the papers on TrailerBits with the fuzzing statistics as well. Fuzzing with like properties. It was a while ago, but it was quite remarkable how many. I mean, I don't know, benchmarks are up in the air, but if they are true, then it's a remarkable finding of it was around like 60% plus of, I guess, criticals found if you just do like property based with fuzzing, right? And that creates a question of how do you even create a good property for code base?
That's a fantastic question, and I think that's one that I think it's something that we have a lot of internal experience with like finding these properties over code bases. And so a part of it is that practice of looking at a code base and while looking for vulnerabilities, also looking for like when does state change? What are things that should hold true essentially in a code base? That's kind of what I mentioned before is like the paradigm shift, because with unit testing, you say, I call, transfer, I expect the balance of like the sender and the recipient to be different. But the invariant for like a transfer per se for an ERC20 is not going to be function dependent. It's going to be state dependent. So it's something the balance of like any one user can't exceed total supply. That's not necessarily saying I'm going to invoke transfer. We're basically just telling a kidner, like telling a fuzzer, this is the invariant I want to test. And the fuzzer is basically coming back and saying, oh, but it's violated if you do this certain thing. I do think it does take a lot of time and practice of like being able to sit with a code base and say, in addition to like function specific invariants, what are state, when and how does state change within the entire contract?
And then kind of connecting them all together of what state depends on what state through that. Yeah, it's quite interesting. When I don't know if you already have like preset prices at TrailerBits for a code base, or it's dependent on a whole bunch of factors, but I don't know if you do you know about like the pricing of how it's done at TrailerBits at all?
Not really.
Okay.
I think that's more of we have a whole team at TrailerBits that handles kind of the like level of effort scoping and like the pricing. And so we get to focus solely on the fun of code.
Yeah, makes sense. Yeah, from like what I've been told already, it's more of just complexity, lines of code, depends on if it's math heavy or not, something like that. And I wonder if you do extensions as well, right? So if you're going through a code base and you think you need more time to like crack the case, do you like offer extensions, and do people actually like take that as well?
I think it generally depends on the project and kind of on the circumstances, on how, I guess, how many resources the client has on a lot of their timeline. Do they need to get this deployed soon? It's a lot of moving factors, but we definitely try to, like, wherever possible, be able to essentially provide value for clients. And I think that value can be in vulnerabilities, of course, but that value can also be in like system architecture, higher level recommendations, design stuff. And obviously if we do end up creating fuzzing properties, We deliver that to clients, so clients get to essentially continue building off of that. So I think it's all about trying to equip these projects with as many tools as possible, so that either the next time they like deploy or the next time they get a review, that they're able to essentially find like the low-hanging fruit, or kind of have like a step up on finding those vulnerabilities first.
Yeah, for sure. Having all these different tools, given to them from a cybersecurity team would definitely help them in the future, and how to improve, etc. And just the audit alone isn't good enough. You've also got to convey it in a way that's readable and understandable by the client, whether they're a developer or not. So I imagine, at least half of them would be not developers. It'll just be like the CEOs being like, okay, we need an audit. You've got to be able to convey it to these people that aren't actually technical. And I guess, how do you really do that? How do you lay out, audit report, structure it, and make sure that you get the point across while providing proof and etc. how things are done?
Yeah, that's a great question. So generally, all of our issues are intended to be read in terms of like a non-technical person should be able to read it and say, it's fine, I don't understand the code, but at least I understand the impact and what it could do to the system. At the very least, that should be evident in like all of our issues. And that's why we try to make sure that the description is like straightforward enough to help those people understand like what could go wrong, and help developers understand like how can they fix it and like what they can do to prevent it in the future. In our reports, we also have the code base maturity evaluation. That is like a point in time assessment of how is your software development lifecycle? Are there any improvements you can make to like how you're approaching and how you're writing arithmetic? Less about number of issues that we've found in arithmetic, and more, this could be problematic in the future. This is like something you can add to your process so that you can reduce the impact, or like reduce the chance of having a bug in like arithmetic in the future. And so that is not particularly a technical section of the report. It's more just guidance on what can teams do, and kind of what are areas that they can improve so that they're able to find these bugs basically as they're introduced.
Right, yeah. Sort of just going the extra mile and teaching them how to basically, what you've done to get to the point of finding it. Yeah, which makes sense. You want to improve the developer kind of experience. But yeah. I guess it's kind of like a trade-off of, you're giving high quality, but you're also teaching them to basically not need you anymore. But I guess it's still, it still works, right? Because they're still coming.
I mean, I think there's just a lot of vulnerabilities that can be found through like static analysis and through fuzzing and through unit testing. And I think if we can get the community in that place where they're able to and they're comfortable with using all of these tools like right now, that means contracts, like the code bases themselves, should be safer. And when they get into kind of the stage of doing like a security review, there might still be bugs, but at least those bugs are going to be kind of higher level architecture, or maybe how they're approaching like something in the code base, as opposed to, for example, like initialize can be front run kind of issue. I hope at least that these tools allow developers to catch them early.
Yeah, I agree. Just being able to find these, the basic bugs that you can find for just unit tests. I think nobody should really get an audit unless you do full, really comprehensive unit tests. It doesn't make sense because you're paying experts to do an audit, and your goal for that is to find, game theory stuff, the things that they've basically been trained for, or, had multiple just crazy experience about. They don't want to you don't want to hire them like these professionals that, specialize in this game theory just to find the very stupid basic bugs from just, a unit test of like, okay, this isn't meant to like downcast and lose all of the, the bytes or half of them from like uint 256 to uint 128. So all that stuff can be just found within a basic unit test. But I guess how long do you even spend on the audit report as well compared to the time you spend on the actual audit?
Yeah, that's a great question. It also very much depends on the number of issues that we raise during a review, and whether it's like a full report, so a report that contains like issue descriptions within the report, is likely going to take longer than one that's delivered like without those issue descriptions. I do think that report, even though it can take some time, is definitely a really important deliverable for those clients, because that's generally showing for like not only what we did during the code base, but provides like a lot of recommendations as to like what they could do in the future to prevent similar issues, or what they can do in terms of, or what else they can do in the future. So I think it's definitely, it can be challenging for some people, I think, to switch between, code review and like writing a report. But I think at the end of the day, it's hard to like put an exact number on like how long it takes. But I think that's generally a really important part of the review.
Yeah, and obviously being in a team as well is a different environment to auditing solo. I don't know if you've done private audits by yourself solo before Trailer Bits, but what does auditing in a team really look like? Because most people just come from, they only start on like a public contest kind of platform, or they just have private clients and they don't really want to, or haven't really been given the opportunity to jump in a team. But I think, what are the benefits of being in a team, both growth wise and also efficiency wise, in your opinion?
Yeah, that's a really good question. I think for me, that's one of my favorite things of working at TrailerBits, is being able to work with, in many cases, just a staff, at least 2 engineers on a project. So
Like
we have some that are 1 engineer on a project, but we try our best to have 2, just because we're able to bounce ideas. We're able, if one person focuses on getting kind of a mental model of one aspect, then the other person is able to focus on properties, or focus on how do their test cases look, and like what bugs might have been found in the past, and be able to almost split up like that task of being able to understand like what the code base does, and then you can kind of regroup and say, this is a part that I understand and this is how it works. And if you give, I think, everyone on the team that opportunity to do that, you gain that idea of like expected behavior much quicker than like if it's just one person. And I think especially with like all the changes within the blockchain space, I think when I first got in 2017, like there were obviously very quick fast-paced changes in general, but it wasn't necessarily in like all of the different fields of blockchain. So like we'd see a lot of developments in terms of like DeFi, but then like everything else would kind of be, or at least it was easier to keep track of everything that was going on. I think one benefit of having such a large blockchain team is that everyone's kind of very interested in different aspects of developments in the community. And so we're able to like share that knowledge without having kind of one person have to keep track of like, all the updates with like different L2s and like different tokens and updates to like Geth and that kind of thing. So I think that even that opportunity to like bounce ideas, not just on individual audits, is a huge value add, because we actually understand kind of the changes in the entire space.
That makes total sense. You're in an environment that's very catered towards what you want to be around, and so that kind of propels you forward into that kind of specialty of getting to the elite level, because you're just surrounded by people like the same caliber, if not better. And the people that aren't at that caliber, they quickly get up to speed, because if you're around these people that are top tier, it's just bound to happen naturally. It's like if you spend your time with a bunch of millionaires, eventually you're going to become a millionaire, right? Or if you just hang out with people that don't have the best habits, it rubs off on you. So environment is a very key thing, and the people around you, the people you really spend your time with, really dictates, I guess, your direction. And yeah, if you're in an environment like that, I think that's kind of the main benefit, actually, because the solo auditors, let's say they're only by themselves, I guess they would only talk to their friends, or their friends could be like IRL friends, which is fine. But I guess career-wise, I guess who would you talk to unless you're in a small team? Or if you're just solo, it's kind of hard, right?
Yeah, definitely.
Yeah, so I guess what do you do after an audit? Do you do any kind of feedback on yourselves, like kind of assess what you've done, and your teammate assesses what you've done, you assess what they've done, and kind of give each other feedback, or is it kind of just move on to the next?
We generally do retrospectives at the end of every audit, just so that we get an idea of like how was like working with your team, how was working with your PM, how was working with like the client. Are there at least lessons learned that we can take in for like maybe like the next audit or like the next opportunity? Is there, I think for tooling in specific, especially, is there anything that we could automate? Is there anything that like we've found 5 or 6 times already in other audits? And can we write, like, for example, a slither detector for that? I think those are generally the takeaways that we try our best to kind of parse out, just because slither exists for us to use, but also for the community to use. And if we're finding the same issue across 5, 10, 15 different audits, it means it's probably something that's it's a mistake that's commonly made. And so that's something we probably want to automate into like a slither detector, just so that we don't have to actually go through and find that manually, but also that there's an opportunity for developers to use that automated tooling to their advantage. So I think we're always looking out for like other things that we can add into our tools to make it easier, make it more efficient, make it better. And I think same goes for all of our performance at work as well.
And would you say like the tooling is a very key part, or is it kind of just like a little additive that doesn't really matter in the grand scheme of things?
I think for us, it's a huge part, just because slither results tell us a lot about, has the client considered potential like violations of smart contract best practices before? And if they haven't, and there's many slither findings, then we kind of know what to expect, at least for the future of the audit. That maybe we'll be spending some time looking for violations of these best practices, and maybe we'll have less time for kind of those fuzzing opportunities. And it kind of helps us determine even just what to expect in the future. And I think for slither, definitely for finding those automated and like those best practices. Echidna, I think more so, in fuzzing in general, more so to find those complex bugs. There's definitely been cases where I've run Echidna and it's maybe found a bug in like 24 hours of running, and then it takes like a day to figure out, what is the actual property that's being violated and how. And generally that's something that we loop the client in as well. We say, there's this property violation, maybe we can hop on a call to like kind of debug this together and kind of work through it, just because clients have, they have the best image of what is expected of their code base. And I think together with kind of that focus on security, it becomes much easier to kind of find those instances. I do think it's definitely, as you get fuzzing up for larger code bases, those exploits get more and more complicated and therefore take more time to triage.
Yeah. For example, like the Pickle Finance exploit, I think a couple of years ago, was just like, I don't know how many functions it used. There's a lot though. I think in like, the evil jar, just one evil jar had like 7 functions. And if it's like an arbitrary address, then you could create the contract. And that's a whole new realm of possibilities, is creating this contract and what to actually call within the contract. And when you're given multiple options, multiple arbitrary addresses, and it just gets even more complex. So I think at that point, to really think of a complex thing, you've got to really analyze it for a very long time, unless you're some human specimen and you can just think of some very complex thing off the top of your head, or you've really just trained for it, like you've done a lot of complex hacks before, or identifying them. It really comes down to experience. In your experience, when you find, for example, an external call, what is your kind of go-to to see if it really is vulnerable or not?
That's a good question. I think the thing with external calls is there's some intricacies, related to the usage of like the low level call in And that's kind of like the first place to look. Is the client aware of, the effects of using a call or a delegate call? Do they know like the implications and the differences? Do they know the fact that if they're not checking like the contract size, that it's basically going to fail silently? I think that's kind of the relatively easier checks. I think where it gets complicated is what is that external call actually calling? Who controls like the contract that it's invoking? Is it permissioned? And most importantly, like what if it's just like an arbitrary call? Like what are all the potential implications of what might go wrong? And that list can be fairly, like, it's hard to be conclusive there, because if you're allowing like arbitrary calls to like 10 different, and if you're allowing arbitrary calls in general, then it means you're basically opening up to like an unlimited number of like DeFi protocols or like marketplaces, that kind of thing. And so the implications there are much harder to actually check. I do think that's one area that like it's kind of, we'll try to provide as many recommendations as we can around what to look out for, what are like potential side effects. But I think it's definitely useful for like developers to essentially document like, these are the protocols that we expect external calls to be going to. This is the impact on the system. And if there's like any system that that your code doesn't interact with, well, making sure that that's like either explicitly checked in the smart contracts or like written down somewhere in a place that's accessible. It's always a challenge, I think, because there are a lot of risks associated there.
Yeah. And do you guys do like research on, I guess, complex vulnerabilities at all? Like postmortems of post-deployment hacks?
I'm not entirely sure. I personally haven't been involved in any. Yeah, I'm not entirely sure.
No, okay, so no researching like actual hacks going on. It's more of just actual auditing experience. That makes sense, yeah. Okay. Maybe it'll be useful though to get to understand postmortems, and you might be able to identify these complex ones like much quicker, or even just being able to identify them. Do you ever think of really game theory bugs and generate like these proof of concepts which involve multiple protocols, or is that not really a main thing you find?
Yeah, that's a good question. Personally, I haven't focused on like those higher level interactions of different areas. I think we do also have a fairly limited, so we have dedicated time for audits, and then we have dedicated times for like R&D, and kind of it depends on kind of what different people in the team want to work on. Can be tool development, can be enhancing public documentation, can be kind of building up like a knowledge base of maybe a new protocol or something like that. And so I'm not entirely sure whether like other people on the team have explored that, but personally, a fair amount of my own R&D has been conferences and talks.
Yeah, I think just the only way to really get good at these game theory exploits is to really just learn them and understand them, because I think it can be quite obvious to see these in-house contracts kind of bugs, arithmetic, casting, reentrancy, etc. But in the grand scheme of things, when it is deployed, what's actually happening is people doing these game theory ones which involve a lot of protocols, and then they just get completely annihilated. Like it's really common, but then these very simple ones as well, like just reentrancy, are also like a giant cause. Otherwise, it's more of just like oracle manipulation combined with reentrancy in some way. But yeah, the game theory ones are very interesting to read about, but obviously it takes quite some time to understand them deeply. I don't know, I don't really see too many great explanations of what's happening and why it's happening. It's always just this is happening, then this is happening, and that's it. It doesn't explain why they do this to get to this stage. Even as a dev, it's kind of not too good, so I guess the research isn't really there either.
I think there's definitely quite a few areas of just like the industry in general that I'm excited to see like future progressions. I think there's just a lot of room for kind of development and growth. And I think the more that we grow in like those areas, I'm hoping the safer code we have.
Yeah, I agree. There's so many areas just waiting for innovation, especially with like ZK around the corner and abstracts, account abstraction that's going to present, a whole new game
Yep.
with, one wallet basically executing the transactions from another wallet that just, introduces a whole bunch of attack vectors, right?
Exactly.
Which I'm pretty excited about to see. But yeah, it's going to be quite interesting. It has reached an hour though. I don't want to take too much more of your time, but I appreciate this talk and finally getting to meet you as well.
Yeah, for sure. Thanks for the offer. It was really fun to talk.
Yeah, likewise. I thoroughly enjoyed it, and I'm sure the audience has as well. If the audience wants to come on and wants to suggest someone coming on, just DM me at Scraping Bits on Twitter, and I'll see what I can do. Otherwise, thank you so much, Nat, for jumping on, and we'll see you in the next episode.
Yeah, have a good one.